So first of all, I will try to introduce the visionary concept session, which has the aim in presenting and discussing new IoT and distributed computing concepts like swarm computing, containers, orchestration platforms. This is a very important element for future developments in IoT and edge computing. I will summarize in one slide the highlights from future research and investment priorities identified from the previous Fire Chat, the webinar that was organized in March, and introduce the concepts and research priority proposed by IoTI. So first, I will go to the priorities that we identify at the last workshop, and we start with the need to address the collective intelligence in a system with no centralized control. This was one of the important highlights we identify. Then the issues related to heterogeneity and diversity of IoT devices that requires orchestrators or trustable distributed meta-level operating system that will be in charge with managing the inbound and outbound move of data. Swarm computing for self-organizing IoT system, physical and virtual IoT edge system integrated in IoT was another important element, and the discussion around digital and virtual IoT twins in the computing continuum. New ways of programming the intelligent orchestrator using, for example, natural interfaces such voice, drawing, schematics, example based on AI. New IoT and edge computing open, decentralized and distributed architecture are a key to provide cross-domain resource orchestration to assure that we will implement the Continuum X end-to-end capabilities. Then we discuss about the methods for updating and upgrading multiple IoT devices and providing parallel processing capabilities. The advances that are needed are focusing as well on operating system and orchestration mechanisms to address the heterogeneity of devices and technologies while trying to integrate lightweight virtualization, virtual machine, microservices, containers, and unikernels. These elements and these topics, I hope that will be addressed in detail in your presentations. Then scalability, efficiency, dependability, trustworthiness, adaptability, and transparency are elements that are key for future development of IoT and edge computing. And last but not least, advancements related to processing, bandwidth, resources management, and orchestration are key for these developments. These are the summary of the highlights from the last meeting. You will find the document with the report at the address that it's listed below. Then I will jump very fast on the Alliance for Internet of Things Innovation and some of the priorities that we discuss within the Alliance. First of all, you have to see the focus of the Alliance from the IoT, from the edge towards the cloud. So many discussions were edge cloud or cloud edge focus. The Alliance for Internet of Things Innovation is focusing on IoT and edge. And as you notice in this picture, I will not go in detail. We have a discussion about the granularity of edge and how you address the micro edge, the deep edge, the meta edge in the different IoT applications. So the slides will be available. I will not go into details, but here you see in a way in one dashboard almost all the elements that are very important for the development of IoT and edge computing. Then this is not only related to some normal application, it's related as well to the new application. New applications like Internet of Things senses and tactile internet. And here we have to consider as well how IoT and edge computing is addressed and what are the tools that we are using, what are these meta operating systems that we are developing, and what orchestrators we can use to have a federation of applications. And now just to summarize the priorities for IoTI in the field of IoT Edge, you see here, these are these 16 priorities. IoT Meta Edge, Deep Edge, and Micro Edge. IoT and X continuum paradigm, intelligent connectivity, energy harvesting and very low power systems, heterogeneous cognitive and mobile IoT Edge, mesh, IoT digital twins, swarm systems, Intelligent of Things senses, decentralized and distributed IoT edge system, federated learning, operating system and autonomous orchestration concepts, dynamic programming environments and tools, IoT system integration, IoT sectorial and cross-sectorial platforms, IoT verification, validation and testing, and IoT trustworthiness and system dependability. With this, I will jump to the area for applying these technologies. So the main 6 sectors that the Alliance is addressing are health, wellness, and well-being, agriculture, farming, food, fisheries, mobility and transport, industrial manufacturing, renewables, and sustainable energy. And the last, it's building and infrastructure. And now I will want to introduce the panel of our experts. So we have Martin Thorngren. He's professor in embedded control system, mechatronics division of KTH Royal Institute of Technology in Stockholm. And his presentation will focus on a vision for trustworthy edge-based cyber-physical system, predictable, safe, and secure. Then we have Norbert Copenhagen, Vice President, Chief Research Node, New Ventures and Technologies in SIP. His presentation will focus on EOS, a European open, secure, sustainable edge mobile platform. Albert Söberg, Director Global Strategy IT in Cities and member of the scientific community of Atos, will focus on data-driven city. Marc Duranton represents the research community. It's Research and Technology Department in CEA in France. His focus will be on interoperability, composability, and smart meta orchestration systems. And Carlos Bravo, which is Director for Strategy Execution, CTO Office at Ericsson, will focus on edge computing, enabling digitalization of industries. With this, once again, thanks to the speakers for accepting the invitation. And I will invite Martin to take the floor and present his vision on trustworthy edge-based cyber-physical system and how they are predictable, safe, and secure. Martin, the floor is yours.
Thank you very much, Ovidio. I will share screen if you
Video, could you stop your screen?
Yes.
Thank you.
Thank you. Can you see me and hear me?
Yes.
Thank you very much. Good afternoon, ladies and gentlemen, and greetings from Stockholm. It's my pleasure to present this vision, and in addition to what Ovidio just said, I'm also directing the relatively recent Stockholm-based research center on trustworthy edge computing systems and applications. And to set the scene for where we are and working in the center, I would just like to share a few industrial applications to give you an idea. And essentially, we are emphasizing humans. I will come back to the automation paradox, which I think is very important to remember these days how much the more we automate, the world does not necessarily become easier for humans. Humans will interact with these systems we are building in different ways. Here's an example, industrial manufacturing, assembly of aircraft, cars, and so on. In these systems, we can augment them with AI and edge computing, IoT, to, for example, do predictive maintenance, to do anomaly detection, and by doing so, we can actually improve sustainability and safety and many other things. At the same time, we are introducing new technologies, and it's important to understand their failure modes and effects because we don't want to compromise availability in industrial manufacturing. Another interesting use case is from our partner Elekta, where they are closing the loop, and it's kind of an amazing case. Elekta are known for their radio therapy, for example, tumor treatment with radiation. And then you put the patient on the table and you fixate their skull and you can, in an efficient way, help them. However, people move on the operating table. So you want to take the real-time motion changes into account. Obviously, this is a delicate, real-time, very precision, intensive activity, which is also safety critical. And finally, we put these things together with analytics, closing the loop, collaborating systems, whether in manufacturing or intelligent transportation. And this creates an enormous amount of opportunities, but also challenges. And when we started TACOSA, we were pleased to find that many of the companies, they shared the same ideas for innovation, but they also shared the challenges. And essentially, there were 3 challenges that we highlighted as part of trustworthiness. And we have, in previous sessions today, and I'm sure today we will hear more, we understand that we have to reason about the end-to-end activities of these systems. And it's not only about speed and latency, it's very much about predictability over end-to-end chains. And it's known, for example, from cost-efficient fault tolerance, that to be cost-effective, you have to look at both the applications and the platforms in conjunction. We are believing that we have, with the heterogeneous landscape, we will have more attack surfaces. We may have less resources. So security is key. We have to deal with the deficiencies or the vulnerabilities of machine learning. And there's a lot of interest in exploiting machine learning at the edge while preserving confidentiality. And then many of these systems are availability critical, and some of them are also safety critical. With machine learning and edge computing, we have new failure modes. We have to deal with uncertainty. So we have to deal with the probabilistic behaviors of these systems. We need new architectures, and we need people to actually feel safe. So having been up for 1 year, it has been a very interesting year because we also had a pandemic year, sad and interesting year. I wanted to share some further challenges that we have come across. And here's an example, just sketching out or fleshing out an intelligent transportation system or a piece of it, where you can think of improving traffic efficiency, traffic safety, road maintenance, the vehicle as a sensor. There are lots of opportunities here. And in the discussions we have had, it's clear that we are forming new ecosystems, many new partners or constellations. And the first challenge is really to reconcile the worldviews. So the taxonomy, for cloud people, the cloud is the center of the universe. For the machine developers, well, the car, the embedded system is the center of the universe. When we speak about far edge, whose edge? And there are different architectural principles when we want to integrate these systems. We want them to be interoperable and trustworthy, and that's really a challenge in reconciling this. And as you're well aware, in IT and cloud, for good and bad, the physicality has been abstracted away. That's well known in computer science, and it's a highlighting challenge. But the physicality, real time, energy, safety, well, they're not visible in the abstractions used. At the same time, at the embedded edge, we are not having the scalability, and we want to leverage the strength and deal with the bottlenecks somehow. So the first challenge is really to build these ecosystems and bridging the gaps. The second challenge, which I'm sure we will come back to, is that we have all these different trustworthiness aspects. Each of them faces a challenge. End-to-end latency, for example, failures, security hacks, they are all interdependent. And in the end, we are creating rather complex systems because we want new capabilities, and humans will interact with these systems. And when they fail, because they will fail, humans will have a hard time to deal with that. We need to think about the automation paradox. And then one of the questions I posed for the panel, which I think is essential for Europe, is how we can accelerate the introduction of these types of systems, with ITS just being one example. Of course, there are many other domains, as Ovidio mentioned. So we can think about Tesla, and clearly they are not very precautionary, and they are actually experimenting with automated vehicles at the expense of people's lives. They are not attending safety conferences. And of course, Europe wants to strike a balance here. So coming to the wrap up, I think starting out with this ecosystem, in my experience, one useful starting point is to promote the collaborations. And in Stockholm, many years ago, I started a competence network that actually have been catalyzing projects, including most recently this research center. So I think these competence networks are very important. Test beds and innovation ecosystems are important. Open data, we can experiment, we can work with guidelines, etc. And there will be many of these with different targets. In Sweden, we are working with test beds, and we have seen the need and been asked to coordinate regionally and nationally, because many test beds are emerging for infrastructure in different domains. And there, in the best of worlds, we can coordinate and leverage these different efforts. I think many of you would agree with me that trustworthiness needs to be first-class citizens. For example, we see many reference architectures in this area of IoT and edge. They do not tend to have trustworthiness aspects, or maybe one aspect or part of it. We need more of that as part of these efforts. And these systems will be complex. We need to design in these properties from the beginning, and we need to make them resilient, because and in addition, we need to deal with risk at runtime to detect ongoing attacks or safety hazards. And with these words, I would like to conclude, and more information about the COSA is available here. Thank you for your attention.
Thanks, Martin, for a very interesting presentation. Perfect. So then we will move in the data-driven city that is built by Atos, and Albert will give us the insights.
Thank you. So yeah, in the past decade, we've been working on what everybody then was calling the smart city or the intelligent city. And from what we understood from beginning is that we had to work on how to capture, share, and analyze data in a way that is respecting the privacy of the people in the city, that's trustworthy and reliable. So all the buzzwords, Martin, you use are in place for a smart city, because in the end, you build trust on what it is delivered. So on the, and we're proud, so we put that in, we're proud that based on the innovation and the constant strategy, we were put in the smart cities leader position by IDC. So it's a, but let's get that, go to the next slide, please, Verena. If we look at cities, we do not look at one specific technical or vertical element. It's the combination of the, I would say, the silo departments that have the real issue here, because public safety is directly impacting our economy, and that means work and education. But mobility, again, is directly impacting the quality of life, or let's put it in a paragraph, sustainability. And in the end, everything is connecting to our citizens. So that means the data we generate, we are citizens, we live in our city, we generate data, we capture data, but we need information to make better decisions on what we do, when we do it, where we do it, and how to facilitate and participate in the overarching cities program. So yeah, the transmodal shift, we talk about mobility, autonomous cars, but in the end, it's us that need to change the behavior, and we need to be able to connect and communicate with the city as a system. Next slide, please, Verena. So that means Edge, when we started some 8 years ago with the first project on public safety, we were obliged to start working already with the first Edge technology, because we captured video in a public space, and we were not allowed to store data on people in public spaces without that permits. So this is why we analyzed in the camera, changed the footage into red dots that we could put on a map. So there was no human data captured, nobody's person was recognized, but that red dot was moving, and we did the AI on the red dots and the movement patterns of the red dots. So that was a privacy reason to do this. That's very important before we took the data in. But it's also, in the next slide, Verena, it was also very important that we could not take all the data in, because the second topic that we started analyzing was sound. So not decibels, but megahertz, so spectrum. What is happening? Are people aggressive? Are people in fear? What type of sounds can we recognize? And that means if you do a refresh every 10 milliseconds, you will bring in 60 megabytes of data every 10 milliseconds from every sound listener. So that's a network we couldn't build. So this is where we had to use Edge, and our CEO then called that the post-cloud era. So we need to handle the data where we capture it and make sure that we run the analytics where we can. So these were the two challenges when we started first in a data-driven city to work on and work with Edge IoT networks. Next slide, please, Verena. But if you then think what the data-driven city really is, and Martin, you touched on this as well, we need to build a trusted environment, because we as citizens will rely on the information presented to us and base our opinion on it and act accordingly. So the whole IoT, whole sensor network with Edge devices needs to be monitored and operational. Every element needs to be secured and manageable. So that means you need, as we do in LoRa networks, you need your IoT or your security, sorry, your Edge appliances as a software layer in the LoRa network to provide security. So there's many levels of Edge that you deploy in your networks already. And but the overarching view is you need to do that. I'll come back to that later. In the middle, it's of course, we can skip that. It's about the collection of data, making sure the data is ready and available in the right format for the right use cases. The data management layer is a new function in cities that mainly doesn't exist yet. We have chief data officers, but they're innovative people. They're not really operationally in control of the data. But on the far right side, we see the data-driven services. And here's where the future of Edge will come into place, because interacting with the city as a system means we share privacy data. We share our own profiles, because we tend to use certain sets of data published by the city as the system. You can imagine, just as an example here, if you're in a wheelchair and you would use a tube in London, the minute you hear mind the gap, it basically tells you can't leave the train. But if you do leave the train, and you can leave the train, you still do not know whether you can go up to the first floor, because the connection between the train and the elevator data is not made possible yet. But the more important thing for you as a person, if you can access the combined data sets, you tell the system you're at least a vulnerable person that needs that information, because not everybody will use that. So that brings up the challenge to say, well, we need more ad hoc type of IoT and edge networks, where my phone is a part of the network. When I switch on the app, and with my personal profile on my app, I'm searching for the information on the net, edge net in the city, to get the information I need. So that's really personalized data-driven services in an IoT edge network. Let's go to the next slide for you now. So that means we created a platform that's just for the data. It was the middle piece of the prior slides, but we have to embed that in an infrastructure that is ready to exploit. So the most important thing is, and here's where we work with the OASC and many cities on what we call explainable AI in our scientific community, or fair AI, but at least it needs to be edge executable AI to make sure that we have the response from the city the minute we need it. So the AI can be developed somewhere in the core. I'm using different terminologies here for meta, deep, and micro, but for me, it's a core environment, or it's local, or it's far edge. So that's a very important element. The edge and the IoT layer should support a privacy by design approach, because you don't want to be in the police state. You want to be personalized, and personalized services should come to you. And so it needs to be trusted, secure. We use edge to secure the networks. And of course, it needs to be open, a platform of platforms approach, because there is never a city with only one vendor. There's multiple vendors, so we need standards, open standards to connect all the services on top of an edge IoT network. And there's a lot of challenges on that that we need to crack. But the convergence of the network, so the ad hoc networks, the development of open standards, and the next phase, it will mean for to perform audits in the edge IoT network. We should be able to operate a distributed ledger system that gives us the opportunity to track and trace what was happening on the network. We too much focused on how we build the technology, but we should start thinking of these use cases already before we finish the design of a network, because these are vital elements for a successful network in cities. Next slide, please, Verena. So that means the connecting the dots in the city. We talk about public safety. I've mentioned that already, how we use edge for privacy. Dimension of mobility. There's many reasons why we want to change our mobility patterns in cities. But the most important thing is, again, here is trust. So collaborative ITS is only successful if we really can handle the fast volumes of data at the far edge, because we can talk about vehicle to grid and grid to vehicle, vehicle to vehicle. If the sequence of processing the data is corrupted at any moment, we can't trust the system. And it's even getting more complicated if we talk about urban air logistics. So autonomous drones, so beyond visual line of sight flying drones, we use them in power line inspections. But if you want to operate them in cities for logistics or surveillance functions, these drones need to communicate to drones. So all of a sudden, the CITS, which is basically on foot level, gets into 3D with the different dimensions of the network that we need support. And then, of course, there's more elements on privacy, the connected homes, the campuses. And I already touched on the sound pressure as the volumes of data we should have to be able to transport. But the health topic, you can deepen that. If cities with the pressure on helping people to create a more healthy lifestyle, supporting them in recovery after operation from hospital, but also more on personal services, what to do and how you can operate this. Even personal with COPD, and the data on the weather is important to mention and measure it, so you can inform people to be prepared and take caution of what's happening the next day. It's all about these little elements that you need to be very careful about. Next slide, Verena. So going forward, it's very important that the network is AI executable ready. So that means open standards. We do some research on explainable AI, but it needs to be fair AI. So transparent, explainable, not black boxes. You need to be able to make it work. On the middle side, we see that the edge networks, the IoT networks, should support the capability of what we call shared experience. I mean, it's about operating and in use. Simple things. In Malaga, we connect all the public transportation. So every bus and the completion rate of the buses is available for the back end, maybe to control the capacity, but it's the front end, the user, that needs to have the same. And the way we visualize that data is very important for successful. So if we can do that with virtual or augmented, but on a phone, you already have a 3D option to present the data, so you can work on that. And then that means the connection from over the networks. And I was hoping that at some point we can start working with public or communication service providers that will embed edge according to standards in a public network, so you can build it everywhere where you need it. And then, of course, using it properly, and it is very important that we have a power reduction in the whole IT setup for, in my case, for cities. Next slide, Frena, because I think I'm at the end. Yes, I finished here, so I'm happy to answer questions when we finished all the presentations.
Thanks, Albert. I will suggest that we move on to the presentation from Norbert, and the questions will follow after all the speakers have presented their positions. Norbert, the floor is yours, please.
Hello, I hope you can hear me now. It's Norbert. Can you hear me now?
Yes.
Perfect.
Wonderful. That's good already. This is an advantage when you hear me. I can even see my screen now.
Yes.
So EOS, what is it? We started this year, and I would like to introduce you today to EOS. It's an European open, secure, sustainable edge mobile platform we're working on. It's an initiative, just as I said, recently started. The background is, I think we severally already iterated. So yeah, edge mobile computing devices like smartphones, natural part of our life, be it in private life, as we see now in pandemic times. So we have critical health applications running basically on infrastructures predominantly out of North America. So dependent also on, let's say, Bluetooth infrastructures and so forth, or let's say technologies and so forth. So we have more and more bot applications in businesses, in a private life and so forth. We have, as I said, like stress computing or flow computing components, as well as we are researching those elements as well. So this data element gets more and more private, gets more and more, this data needs to be more and more protected, and the systems need to be more and more secure. And overall, we are talking about, I think this was iterated already this morning, about digital sovereignty of Europe here, and this is what we like to contribute with the US. So as I already said, beside of this, we see that it's very dominant. We see basically three, let's say, portion of markets. We have basically domination of North American. We have Russia, China, and so forth, building up their own infrastructure, seeking also for more, let's say, independence. And I see personally Europe as maybe there's some room to create maybe let's say new things on this. So enforced by this, by very social, economic, earth preservation challenges and so forth, I think it's crucial for also education use cases, healthcare already mentioned, defense, public sector, NGO, enterprises, all kind of discrete and let's say discrete and process industry scenarios. We are working it in SAP, and I was quite astonished when I have been talking to coming basically from the health sector in context of Corona, let's say applications, looking then also looking into our dependencies, our heavyweight dependencies on North American infrastructures. So and then we basically talk with a lot of our, let's say, sectors, with the industry sectors, also for automotive industry, tier 1, tier 2, tier 3, and so forth, but also with chemical industries or machinery industry and so forth, and also governmental sectors and so forth. And was quite astonished how open people have been, and it seems to be also a matter of timing to come up with something like this. So as I already pointed out, and I keep it short, I mean, just looking on maybe one of the major operating systems, how this evolves. So Europe is, and I'm here, I'm a little bit more on the black and white side. So Europe is only existing as consumers of those kind of platforms and such kind of products. And we are the data providers for edge and mobile markets. So we are not really, from my point of view, not really players. So we founded these initiatives, and there are also some dots here. So it's still filling up, let's say the core, let's say round. We are also dealing with quite some letter of intent. So we have quite some interest, as already said, from automotive industries and so forth and so forth. And these are some of the core team in the moment we're working with. So our, let's say, cognitive team, like Shiftphone, they are building, you have maybe known them or know them already, like a little bit similar than Fairphone from the Netherlands. Shiftphones are building an alternative sustainable smartphone, currently running on let's say, derivatives from Android. So Android as maybe the most public or most common known, let's say widespread operating system. We are dealing with some technical professors from and working with them, and from the University of Hanover, and for instance on Mannheim, for instance. We are dealing with, or we are not dealing with them, but working with them with Vodafone as well as Telephone systems, for instance. You're all aware of UB ports. So Vodafone, they are basically also hardware providers. Their phones are very well known as well as a sustainability provider, phone providers. You all know maybe Ubuntu or Ubuntu Touch as a, let's say not native Linux foundation for in particular for desktops and laptops. And the canonical, let's say, IP got converted or transferred, maybe better to say, to UB port, which is located in Europe. And we are working also very intensively with those guys. And yeah, we have also some, let's say, opened up, of course, very open to small and medium enterprises like Pancreative, which is a new enterprise. It's a media platform or media, let's say, company. It's a startup basically building, let's say, or their target is really building, let's say, new type of interaction patterns and new type of software and hardware interaction patterns for people with the internet. So a kind of rehearsal or renaissance of the original thinking of the internet as a common basis, or let's say a basis for equal exchange of knowledge and information, going beyond just commercial or let's say marketing perspective. Yola, of course, to mention, from the ex-Nokia people, or most of the people are from Nokia, basically in Finland, great guys as well. They are distributing and let's say engineering the Sailfish OS. So with them we are working, and we are reaching out currently also to more partners who showed already competencies in building such kind of, let's say, operating systems, not only for smartphones. And EOS is, let's say, taking the mobile term pretty broad. So you could think of, as I already mentioned, mobile is basically everything. We're always mobile. So of course, the smartphone market is a very interesting one. But we have also, let's say, all times are moving, all times is everywhere is data in IoT. Recently, we are working also with the European Commission and with Ministry of, let's say, with Education and Research in Germany, to drilling down how we can really execute and exploit, because as you can imagine, this is not a small thing to build something out of this. But the good news is we don't need to let's say, start from scratch. There's a lot of expertise in Europe, in there, also in my company and SAP, building, let's say, cloud platforms, also being engaged already in Gaia X, like other partners here as well. So we can really leverage what's already existing and the different initiatives that have been driven by the national, let's say, initiatives, but also in the European Union initiatives. All right. The proposed timeline, to keep it pretty short. So officially to start this kind of, or convert this kind of initiative into a, let's say, really executing engineering exercise as an open source platform in the next quarter, basically start with this. This is on target. We plan to show some prototypes already in the course of the first half of next year. as soon as possible to make it very tangible, that you can see how this thing looks and feels like. And I will show you an architecture slide in a second that you can also have, let's say, a little bit of preview how EOS could look like. The MVP tool is called, obviously, MVP means minimal viable prototype or product. It depends also from the commercialization, also in our market research, also working with the hardware and semiconductors industry in Europe, what we can do here and what we can really, let's say, bring products to the market which can be already used in, let's say, commercial business scenarios or end user scenarios and or. So already, let's say, coming up every year basically with a new minimal viable product or prototype with EOS, showing products on top basically on the EOS stack basically. Then in 2023, come out with a major, maybe having several commercial devices already running with EOS as an alternative to maybe Android, and then achieving mass market readiness by end of 24. That means mass market readiness means that we have a solid foundation and a distribution of EOS, in which terms and conditions we need to see in general will be GitHub repository, which is already existing. We are building this up right now and launching it to a certain point of time and giving more details. And currently, maybe to mention as well, currently the state is that we are working in, let's say, I think we have a very good picture on the details of the architecture and how to build it. We made some proposals already how to set it really up in terms of technical details, in terms of abstraction, and so forth. I'll come to this in a second. And of course, we are looking in the moment how we really come in a concrete execution mode, also in terms of funding, obviously. Yeah, it's basically all about unbundling also on the edge devices, unbundling hardware and software. We believe this is also plays into the sustainability. Currently, for instance, take the smartphone market. Smartphones are the average lifetime of a smartphone is a little bit more than 2 years. Obviously, this plays very well into, let's say, the business models of hardware and software providers in that market who are dominating it. On the other side, it's not really sustainable. And it's not really a business which is happening in Europe. So we are talking about a massive market, which means also, let's say, possibilities for employment and so forth in the European community. So from the architecture perspective, maybe taking it up from the bottom level, from the, let's say, overall SOC level. So we are building it up on a powerful ARM devices. As you all know, ARM architectures are basically engineered or foremost engineered in Europe. So building on top of it, as more and more smartphone device providers are setting on those risk infrastructures, sitting on those risk infrastructures. And so what we are building here is basically on a stock Linux, so unmodified Linux built on top, and with some components to really get free of Android. That really means quite some work. Obviously, this is not let's say straightforward engineering, but I think, or we think, that's doable. As we have quite some let's say experiences also in this, let's say, consortium I just pointed out, or a partner network I just pointed out. So abstraction of the firmware blobs and so forth is very, very important. We know, of course, that most of the let's say microprocessor and processor industries partners coming also from Asia are orienting themselves on Android, let's say, distribution. We know that, of course. And step by step, we try to be more and more independent when it comes to this abstraction layer as well. So the major part of the engineering is about actor sensor abstraction, laying out the APIs that we can really build up or foster a kind of a community building on the open source EOS stack. We call the base level, we call EOS X. Let's say a little bit, let's say a correlation to Gaia X. Here we talk a little bit more on the edge side of the house. Of course, we are dependent on a solid, secure, according to GDPR infrastructures, having this kind of interaction, and this has been several mentioned in this symposium here between, let's say, in European, let's say, cloud standardization like Gaia X. We are heavily, let's say, working together with those guys and having here an initiative basically on the edge perspective. The overall interesting idea, which is maybe also an USP of EOS, is the target that we have, as I said already, an unbundling. So basically, based on the EOS, you can basically deploy on a, let's say, virtualization. Predominantly, we are looking into LXC, let's say, virtualizations, lightweight virtualization. We're having different containers. So basically, virtual operation systems running on top. So you could imagine an smartphone, for instance, taking it, or having a smart pen or a smartwatch or whatever, or a smart device on the shop floor, which is accumulating, for instance, different, let's say, IoT information, or running machine learning algorithms, or even steering a car in smart cities. That you have separate containers built on top, maybe based on the model description and the model specification of the specific device. So, but it could also run without having a major, let's say, overhead on energy consumption, several containers on the same, for example, smartphone. That's okay, that you can basically switch back and forth between the different containers. You have maybe an AOSP, Android open source project, kind of, as you see it here, you have maybe an up runtime for AOSP, Android open source project with the platform services, generic ones, and you can run basically, or the target would be, of course, to run also Play Store apps and so forth if you would like to do so. On the other side, we have maybe, you could maybe run it on a different environment and company-specific container for the office environment or the specific plant environment, which is totally, let's say, secured and protected maybe from, let's say, threshold from attacks from outside, maybe using game tools or using private tools or using messenger tools, which are not allowed in a, let's say, certain environment context. Yeah.
Thanks, Norbert. So I think what maybe we can continue on some of the details during the
just
session.
One last sentence, please, and one last sentence, and then I'm finished. And I'm happy to answer any questions, and hopefully there are some. And also finally, of course, that others, let's say, for instance, new enterprises, companies can build their own containers, or service providers, or ecosystem basically in Europe can build on top of the US platform infrastructure. Well, I think that's all I want to say, and thanks a lot for your attention.
Thanks, Norbert. I think we'll come questions and we will discuss more in detail later on. So let's move then to Mark. Mark, the floor is yours. Try to keep the time in order to have some time at the end for the questions, for details. Thanks.
So do you see my screen and do you
Yes.
hear me?
All good.
Okay, so thank you very much for the invitation. So my presentation will be about interoperability, composability, and smart meta orchestration system. And it's one of the output of the IPIC vision. So IPIC is a community of a computing system, so academia and industry in Europe. And especially this will be a part of 2 articles where you can dig if you want more detail. So the one on the Guardian Angel, and the one on the continuum of computing enabling technology, all this in the IPIC vision. So let's start with the physical world and with all the sector of the economy. So going from home to industry to transportation, energy, smart city, medical, and so on. So all this in the physical world are dealing with physical quantities that are captured by sensor and that are controlled on the feedback by actuators. So this is typically the IoT domain. And this is the interface between the physical and the virtual world. On the virtual world, so of course, they get data from the physical world by the IoT devices, and some action are provided to give feedback on the physical world. And of course, all this a platform need to be cross-sector to avoid a silo that lead to have a common and interoperable technology, because the added value is also in the interoperability between sectors. So for example, with a smart car, with an electric car, you could offload the peak hour from electricity consumption, and it could help be linked with the smart city traffic system to avoid a bottleneck or congestion. So all this need to have secure exchange so that the user are safe and protected. And these exchanges could be, of course, short distance, long distance, using wire or wireless like 5G. That will be a big enabler for this. So, and what we also consider is that every devices, both from the cyber world and from the physical world, will be offering a service. And typically this service could be done on the cloud, which is a centralized remote platform, but also from local, distributed, and decentralized platform that could be near you, a little bit further. So it could be on the smart devices, it could be on your home or on your car or in the city and something like that. So we have a complete hierarchy between the computation storage, which is local, to the one that are even on another continent. So we need to choose what is the best services that are offered by all these systems. And clearly, an application is not anymore a single piece of software that run on a single devices. So it's really composed of various services that are all across the spectrum from IoT to the cloud. And as it was said previously, it's also very important to take into account the non-functional requirements. If you want to link with the physical world, so all the CPS requirements, like was explained by Martin a few minutes ago, is very important. So time latency is very important. A self-driving car need to have local computing because it needs to be able to detect a pedestrian even if not connected. So it's very important to have this. But it's not only time latency, it could be also non-functional requirement like locality. So if you have data that you want to keep very private, it's better that they are stored locally or not so far, or at least on the territory of your factory or your country. And of course, also on energy. So you could have a service which is with very high performance, low latency, but consume 10 times more than one other service. So depending on your application, you should be able to choose which service will give you the best trade-off between all this non-functional property. So clearly, it's important to be able to orchestrate all these services and take the one where they are the most efficient. And of course, the idea is not to revolutionize everything, but to build on existing technology like IP, like a REST API, and things like that. So for these services, they will appear, they will disappear. We need to be also to deal with redundancy, with the monitoring. So it's very important that all this system will cover what we call self-X, so self-monitoring, self-management, and so on. And what is very important is that for the user, all this should be built on a trustable, distributed, and smart meta-level OS. And for us, OS is an orchestrating system. So as it was said previously, trustability is very important. And the fact is that the system should be loyal to its user, not necessarily to its owner or to its provider, so that a user could have trust in the system. And this should be built on a trusted computing base, so both hardware and software. And here you will see that we will promote to use open source and open standards, because then you can audit and you can be sure that it's a trustable through audit. So indeed, some private data, both for the company or for the personal people, should be perhaps kept very safe in a secure enclave near the user and not far away. And that means that some of the services like this secure enclave, like this secure storage, should be running on edge hardware.
Mark, we have to move a little bit faster to.
Sorry?
We have to move a little bit faster.
Okay, okay. I have 2 more slides, so it will be fast, I think. So the challenge is interoperability and composability. So really, as I said, we need to overcome the fragmentation of this system today that we have today, and to have more open platform and standard. As you see, we have an heterogeneity of all systems, so it's very important to keep this into account and develop systems that are dealing with this interoperability on this non-functional requirement. Scalability is also important because it's need to scale to million or even billion of devices. So I already explained about dynamicity on keeping the security. So privacy and security are also key for building trust. So this is really what is the key to build the next web, which is intertwining both the cyber and the cyber world together, both for industrial and personal use. And it's here also where we need to add intelligence in the system, because this is very complex. So we need to help the user. And this is why we need this smart orchestrator that could help to put all the pieces together. Some of them are already existing, some others need to be developed, and that's where we need. So as a conclusion, it's very important to have this evolution from the continuum of computing, where basically the TCI initiative is a first step. Also to be able to move application and not only code, because I take the example, if you want to take the average of 1 gigabyte of data, it's more efficient to move the average code to the data than moving 1 gigabyte of data far away. So really, we need to be able to migrate both code and data depending to the requirements. So this is based on everything as a services option. And as I already said, it's very important to have the link with the physical world, with the importance of the cybersecurity and also privacy. And as it was said by Max this morning, we need also to have natural interface, a natural way to interact with this orchestrator, because it will be everybody that will need to interact and to construct their own application through natural interface. When they say, okay, I want to book an hotel room, so it will be, in fact, programming all these services together into a nice orchestration. And also, we need to have the hardware based on this, and also in Europe, if possible. So really what we are pushing is to have a synergistic action across domain. So as Martin said, each community said they are the center of the world, but it's only by bringing them together that we could make really this holistic approach that could build the next generation of a mixture of cyber world and physical world, so what we call the next web. So just what we are today with the GAFA is that everything is on the cloud. What we are moving today is bringing some of the operation local to the user with edge processing and with artificial intelligence of things. And we think that the next step will be really to have this distribution of smart, trustable orchestrator that will really interact together, and where the web will be a repository of knowledge and services. So if you want more detail, you could have access to IPIC vision. So that was
Mark. So
planning to explain.
we will come to the questions later on. So Carlos, please, and you have to be very efficient and fast in order to let us some space for questions.
I will try to do my best on that. I should be sharing already, right?
Yes.
Yes, we can see you.
Thank you very much. So thank you for the invitation, and really a pleasure to speak on the forum. Maybe just to start, right? We are at the dawn of a new era. We think that 5G is key for empowering new services and use cases, not only in manufacturing, but actually for a range of industries in Europe. And actually, we think edge is a crucial enabling factor for those use cases and services in combination with 5G. I think this morning it was mentioned that in reality, those industries are not buying edge, or they don't want to consume edge. They actually want to consume data. And what edge is bringing is transforming the way data is being handled, is being processed, is being delivered, and bringing computing as close to the source of data and where the data is going to be consumed and needed as possible to reduce latency, to improve the bandwidth utilization, and so on, right? And it is built on 4 pillars. And how those 4 pillars are provided defines where the edge is going to be. It can be on devices, and we've been talking about smart devices and how devices will get smarter, on-premise in different factories and enterprises, in the network, and the service providers. And what the edge is actually bringing is a faster response. The operations of the data will be closer to the source of the data, and that will allow for faster actions, faster data processing, artificial intelligence, and as we've been discussing. It's also security, because keeping the data closer to where it is consumed means less transportation of data, but also easier to comply with regulations and with data privacy and control of the data. It's also being efficient and effective. Processing data at the edge, there is no need to move the data to central clouds, but also enabling completely new or different use cases, as we said, for example, with federated learning and using artificial intelligence down at the edge. And there is an operation as well. It is important that it's reliable and provides capabilities to run even if there is no connection with the central location, even in cases there are specific emergency situations that will require to be operating locally. We see this edge opportunity happening in 3 phases, and it has to do with the maturity of the solutions, with the maturity of the use cases, as there will be more use cases coming, but also addressing the opportunities where we can solve specific pain points and deliver value. And this is something I will try to come back later. We see a first phase that is happening right now, exploring different use cases with an experimentation mindset, but we see deployments on premises, validating those new capabilities, engaging with devices, and getting that as a first step. Once this experimentation is happening, we get into exposing capabilities, resources, quality of service, different network access, network slices, but also bringing automation and artificial intelligence that will make those edge and networks a platform to those use cases. And then the third phase is where all this innovation will bring those new use cases and capabilities, is where we see a unified and integrated execution environment that will go across the network. It is a heterogeneous system, but will be managed and controlled and orchestrated as one system. This is where we will see the full value of edge materializing. Something that is important as well to understand is that this is an ecosystem. There will be different providers or different partners that will have to work together in order to build those solutions. And this is something we have seen throughout the forum and in the different presentations, right? It will depend on the type of the use cases, on the deployment setups, what are specific considerations, or even strategic questions like geopolitics, but also regulations, etc. It is important that really to engage with all the ecosystem to secure the interworking between those different players, between the networks, the applications, the devices, and a strong collaboration is going to be required. And maybe this is one of the questions that we can take through the QA in a moment. What key concept we see for edge computing and the digitalization? One of them is the orchestration, end-to-end orchestration. Services are built and provided end-to-end, and this requires collaboration across the different systems that will be orchestrated, how all those different capabilities will actually be deployed and made ready in order to make that service to work. And the second step will be to actually secure that those are easy to use. It is about having APIs that are simple to use, that will allow applications and users to access the capabilities without the burden of complex technical knowledge that will require all those heterogeneous and complex systems. It is about digitalization and cloud native. We've been talking about containerization is one of the aspects. Digitalization is accelerating. I think the last year has proven how much more this acceleration will be, and adopting those cloud native principles is going to be very, very important. Having systems that are easily portable, that are communicating between each other through simple interfaces, etc. And that leads to the last one, that is how artificial intelligence will be brought up into the edge. Edge will enable new capabilities with artificial intelligence, and all those data that can be processed and all these learning capabilities that we will have at the edge will allow for themselves to automate themselves with almost zero touch. And maybe just to close and round it up, when we talk about the use cases are simply ways of solving real problems with technology, and likely identified with a co-creation process with multiple partners in a really growing ecosystem that we see in the Industry 4.0. What you see on the screen right now is an example. This is the first wave of 12 use cases that we have on Ericsson Factory. So this is something that we have implemented today, where you can see from using virtual reality for digital twins, drones, augmented reality for remote support and training. I mean, many different examples that we can prove. This is what is happening now. And this is what is the first wave that I was mentioning before, that we are immersed in, and we need to really accelerate in moving into the next. So stopping here, I try to stick as much as possible with the
Thank you very much, Carlos,
timing.
for this very interesting presentation. High speed, high data rate, and low latency. Perfect. Thanks a lot. So then I will go back to the presentations that you had, and I will pick up some questions for you. First, Martin, trust and the trustworthiness for CPS system. What about the link and how you will address the legacy systems, and how you will address the challenges when the architecture will combine several types of combinations, cloud, edge, different granularity of edge, and so on.
Yes, we have 1 hour for that topic, right?
Right, you have 30 seconds.
Yeah, well, I guess it's evident that we will have greenfield new installations, but we have a lot of what you call brownfield. There's a lot of legacy out there, and you will have to deal with it. And you will have to deal with this continuum that Mark mentioned. The legacy, the embedded, the industrial controls. Cloud connectivity is basically there already. Edge is being added with AI augmentation. So I think it points in many directions, but for example, the architectures will be very important. So you can think of having augmentation, but maybe you can add augmentation, but you need to be aware that that can fail. So you need these monitor-based architectures. And yeah, I think I'll stop there for now.
Okay, thanks a lot. So the next, it's Albert from your presentation. Very interesting thoughts around ad hoc architectures, ad hoc applications, platforms at platforms, and system of systems. This is what I picked up as keywords from your presentation. Of course, this is related to the application in smart city. How you see this that can be implemented, and what are the tools that are missing to implement it?
There's a few conditions you need to have before you can start working on that. And everybody, I will understand, it starts with the standards that we need for this. I mean, 5G is a standard, and I think, Carlos, you presented it well, the network as a platform. So if we have that approach, if we see the network as a platform with all the embedded technology that can work on it, the new application for smartphones will allow to have a smartphone become a part of the network when needed, when switched on. I think, Martin, you mentioned that as well. So it's not just the device that is connecting, but it's the application to allow the device to connect at the moment you need it. But that will become then an ad hoc part of your IoT network as long as you need it and you need it to share or use. You don't share, you use your personal data to interact with the system. As an example, this is how we see that. And then the services on top here again is the legacy or the new services, but it's the network is basically multi-tenant and it's multi-operator. So there's more services operations than just the city in a smart city. It's a transportation organization, it's the energy network provider, but it could also be a fast food network where you are a customer, you want to interact with that based on your profile and is using the network. So that's we call that the data economy, but you could also use that as a network economy that's changing, because it's not just about the ticks, it's about the functions you add on top of it, the service layer you put on top of it. And here's where this open architecture of the network in the end will have to come and be aware. And this is also why I mentioned the need for distributed ledger systems, because if you open up the network, you are in need of an audit trail on who did what for what purpose and reason, and maybe even get paid for the services provided.
Thank you very much. Norbert, a question to you. Very ambitious plan to build an open edge mobile platform in the next 3-4 years. What are the players that you feel that you are missing, and how you plan to extend rapidly your ecosystem?
Yeah, it's foremost. I mean, we are reaching out to several more partners. On the other side, we try to do, first of all, come to an execution setup so we can really build in an agile way prototypes and give them also, and then also extend the network with the prototypes because it makes them more tangible to see the real technology in your hands and from different scenario perspectives. The other thing, I mean, when you look at the core numbers in terms of the investments, what is flowing into Android and what is invested there, because it's obviously a very crucial infrastructure for the North American economy and society and so forth, and on a global basis as well. And we are looking to build actually an alternative. And I mean, to raise that, and this is not only about funding, which is also very important here, and we're working on that heavily. It's also about having the right competencies. And so far, what we heard as well from the European Commission, for example, that at least from the organization perspective, and I think even more important on the people perspective, we have, in a moment, I think a good setting of competencies, in particular of people and organization, who showed already that they are able to deliver products, and now it's all about, or it's one thing is really to scale it up. And we are pretty optimistic on the other side, timing, digital sovereignty is all over the place. We saw tons of explanation, different use case perspectives, how important edge computing is. And obviously one of the predominant edge devices are, for example, smartphones, but it's not only smartphones, as I already said. And step by step, concretely building prototypes, tangible prototypes, opening up the open source description documentation also on GitHub and other open source, let's say, platforms, having more discussions on the security levels and so forth. That keeps us, or we are very confident that's maybe also the time now. We looked a lot into why the different alternative approaches maybe haven't had that success like maybe expected. And we try, of course, to avoid such kind of obstacles. And and come up with really an alternative architecture to really decouple hardware from software, bringing up this, let's say, or enforcing this flexibility. Yeah, I think these are the key ingredients of it.
Thanks a lot. So then 30 seconds for Mark, 30 seconds for Carlos. One question for Mark. Guardian angel. How you envision the implementation of such a guardian angel that sounds like a kind of centralized control element, considering the idea of trustless architectures for future edge computing application, distributed application.
Sorry if I intervene very quick, please, because we are running late and we have the parallel session.
Perhaps you could move to the session this afternoon where I could answer in more detail, but I will also answer to the question of Marco on the chat. For me, a guardian angel is what one user sees, but in fact, it's a multi-level orchestrator. So each orchestrator will have his own owner, his own services, and they will all work together in a hierarchical and distributed system. So that's again where you aggregate several services to make a higher level service. So
perfect.
That's the short answer.
So then for Carlos, the last question, again, 30 seconds. How you see the granularity of connectivity to address all the granularity that we see at the edge in such a way that we have a connectivity continuum as well?
We actually have to work in a multi-access technology environment. So we need to combine cellular connectivity that will be used in very strict requirements in terms of latency, throughput, etc. And that will be combined with the other access technologies like Wi-Fi on the wireless side, but also with wired technology. It is going to be a transition. It is important that those edge capabilities are provided on a multi-access technology that will enable those use cases. So we'll see those happening. It has to work across service providers and across access technologies. And that's why the orchestration and this multi-layer orchestration that Mark was mentioning a moment ago is going to be very important.
Thank you very much.